Thanks for having me. Good to see a good turnout, and we'll start off by telling you a little bit about me. So I have a company called Coding Fury. What Coding Fury does is mobile app development, web development. A lot of the stuff that we've done historically has been Bluetooth connected, or there's been a bit of hardware at the other end. I've got embedded software up there. Mostly we're not setting out to be an electronics company, but occasionally an electronics company has worked with us. So we might have programmed a Bluetooth chip on another company's work, so that we're doing the bit of sort of the interface between the phone and the hardware. The other side of the business is training. So the sort of training course that I deliver, iOS, SQL Server, and I'm now introducing, starting in September, I'll be introducing R, and also Python for data scientists. So I'm looking around the room, I'm not sure about this room, but I thought some of you might recognise me from, I also deliver training for Belfast Metropolitan College. I've worked a lot on their academies, their data academies for PwC, Deloitte, EY. Generally speaking, that's bringing in graduates who are not IT trained, they're not got an IT degree, and we give them industry-ready skills. So I've written the courses and delivered quite a few of those. But there's another side to the training, and it's the training that I do through Coding Fury. So these are some of the companies that do through Coding Fury, not through Belfast Met. A good number of them are actually in the south, so quite a bit of it was in Dublin. So that's just a quick overview of me and my company. What you're really here to find out about, of course, is visualizing IoT data. So, I'm going to tell you a little bit about, I actually only put this in a few minutes ago. I thought about it in the car on the way here. One of the things that I've been working on recently was I bought a new house and I put a Nest thermostat in. And I found that the Nest thermostat wasn't compatible with my boiler. So that's what this box below is about. And really what I've got in there is a particle photon. It's a Wi-Fi enabled Arduino, effectively. But it also posts the data to the web. So all you've got to do is do particle.variable and give it a name. And you can then make an API call to that variable, which actually turned out to be really handy, because when I built my system here, my translator, because like I said, the Nest wasn't compatible with the boiler, so I've got my little box in between doing the translation. And the problem that I had with it was that the heating wasn't, sorry, not the heating, the hot water wasn't coming on. And I was able to use this web API to check. And what I discovered was that actually there was a problem with the Nest, and a factory reset of the Nest sorted it out, but the Nest hadn't been heating the hot water according to the schedule, even though everything was set up correctly. So the sort of scenarios that I'm thinking about here maybe aren't production ready, because if you're building something for production, then you're happy to spend a week, 2 weeks, 3 weeks, whatever it is, to build a graph to show your data coming through. But sometimes you're just building something quickly and you want to see the data as quickly as possible, get a feel for what's going on. And that's the sort of scenario that I want to focus on here today. One of my favourite little toys, I should have one in my pocket actually, is the Texas Instruments sensor tag. You can see it here. It's basically a mobile phone without the mobile phone. In the sensor tag you get lots of different sensors. There's light sensor, there's accelerometer, there's ambient temperature, infrared temperature, and the list goes on. And the way it works is it connects by Bluetooth. So it's very quick and easy to get one of these from the Texas Instruments website. You download the app, and you can see the app here on the left-hand side. And then if I click on Push to Cloud, this is a video, so if I tap on Push to Cloud, it actually sends the data up to IBM's Blue Mix platform, and straight away you get to see your data appearing in real time. And if I go down through the list of different variables, which I'm about to do in a second, here we go. So I can select, there's humidity, not very interesting actually. What about the accelerometer? And as this is running, I'm just turning the little sensor tag over to give us a bit of a sense of some data. So you can see there's the axis going up and down in real time. This is lovely. I would love to be able to do this as quickly and easily as this, but I don't really want to subscribe to IBM's IoT platform in order to do it. Surely there's something else we could do here that would allow us to do this. And certainly the guys at the NI DevCon said they wanted to focus on open source software. So my aims were to collect some data from the sensor tag. And I used a Raspberry Pi as a data logger. And then what we want to do is take that data and create interactive animating graphs for the analysis of the data. So this is my data collection process. I wanted to create a random algorithm, and this is my random algorithm here. I stuck one of these on each of our twins who are coming to this July. I'll tell you a little bit more about my twins later on, but they're doing pretty well, as you can see. So I give them each a sensor tag and we log the data. So I'm going to come back to that later, but that's our aim. I've now got the data, now I'm trying to figure out how we're going to visualize it. So data analysis using R, I did say in the brief that we would start looking at R, and this is really, I guess, my first love when it comes to data analysis, was to use the R programming language. So this is an example of the sort of thing I've been able to do in R. This is some data from AFBI, the Agri-Food Biosciences Institute. It turns out that in terms of agriculture, we all know quite a lot about what goes on above the ground, but very little about what goes on underneath the ground. And they had got this device called a penilogger, and the idea is you push the penilogger down into the ground, and as you go down, it measures the pressure in the soil, basically the compaction of the soil. And if the soil is too compact, then roots won't be able to push the way down, and different plants have a different tolerance to this. So you can see up the vertical axis, you've got the depth as you push it down in. So you're starting at 0 as ground level, and you're going down, and then the pressure in megapascals going across to the right. So you get a sense at various different depths how much compaction there is in the soil. The reason I'm showing you this is just to show you the idea that what I love about R is pretty much if I can dream up a graph, I can draw it. Now, one of my things that I preach on about a lot if I'm teaching about data analysis is that you can't identify trends from tables of data. This is a quote attributed to me because I say it a lot, okay? So, to tell you a little bit more about our twins are now 2, but when they were born in July 2015, they were pretty ill. The first year we spent probably more time in hospital than not in hospital. And this is a picture in the early days of one of the twins, and you can see he's got a little tube because they're not feeding well. The only diagnosis we ever got was failure to thrive. Thankfully, they've come through it, but really only in the last few months. But up until that, they'd not been doing very well. They weren't putting on weight, and developmentally, because they weren't putting on weight, they weren't doing the things that you would expect twins to be doing. And my big frustration with being in the hospital was you would meet different staff all the time. They were constantly on rotation. And the doctor would come in and they'd pick up the notes and they'd be looking through tables of data. And I teach data analysts, so I know that you can't tell trends from tables of data. So you see the consultant nodding, going, he hasn't a clue. How could he have? So, of course, what was I doing? I was taking the data, and I was plotting graphs from it. And I was looking for things like, how much milk would the boys suck, which is in green, how much would we have to give them down the NG tube, the nasogastric tube, into their tummies, and it's in blue, so it tops them up to the correct volume. And then at this point, we were starting to introduce solids like baby rice, so you can see that in red. And then I was kind of interested in things, when I started this, I was interested in, what were the trends day on day? Were they taking more from the bottle and less needed from the tube? How much were they taking? If they were sucking, I later added in vomit, so I could see, was there a correlation between the volume that they were taking and whether they were sick after it, and so on. And then I also was able to put it in as night and day, so you can see day is in the sort of the bold and the grey text is the night times. So all of that data was represented, and initially the doctors would refer to my wee graphs until one day I was feeding the boys with one of the nurses. I had one nurse, or one boy, and the nurse had the other one. And in passing, she said, "What do you do for a living?" I went, "Oh, I teach data analysis to PwC, Deloitte and EY." All of a sudden my wee graphs started going into the back of the boy's file. But every time we met a consultant from then on, if they asked a question, we pretty much produced a graph. So I love R, and the things that I like about it is that you can execute the code line by line. So you just sort of do a keyboard shortcut and you go down line by line through the code. And you can go back and you can make a change and continue on. One of the things I like about it as well is the variables are front and center, although that's not quite true. They're in the top right hand corner, but you can always see the data at any given time. The data frames it's sort of an object that can hold data, so it's very easy to read, for example, CSV data straight into a data frame. You don't have to create a class and try and map your data to it. Just read your data straight into a data frame, which is effectively a table, which makes it very easy. Like I say, graphs, if you can dream it, you can make it. And one of the other things I like about R is it's very easy to package up your code and dependencies into a package and share them with a friend. However, R does have some disadvantages. Basically, the graph that you produce is an image, and that's that. So while you can make whatever sort of graph you want, the graphs aren't interactive, and you can't add information to them over time like you saw on the IBM platform, and you can't animate them. So that led me to the Jupyter Notebook, because I started thinking about this and said, well, we've all seen web pages that have interactive graphs in them. Surely I can do something with something like a Jupyter Notebook. Now, if you don't know what a Jupyter Notebook is, it's basically you install the software and it runs a little server on your computer, and it allows you to run Python code. In fact, it started off as IPython because it was for Python, and now they changed the name to Jupyter because it supports many different languages. But Python's probably still the most prevalent. So when you run the code in a Jupyter Notebook, you can see here, not line by line, but you can run stuff paragraph by paragraph. So as I run the code, here we go. You can see it's a web page. You can execute it line by line. You can draw plots. But like in R, the plots here aren't interactive. Now, I've seen some movement towards being able to make them interactive in a Jupyter Notebook, but it's not particularly easy. There's not that many, there's not that much support for it. I see them moving towards this, but I don't think it's quite there yet. So I looked at Jupyter Notebooks, I thought they were good, but ultimately I still had the same problem that the graphs were static and didn't quite do what I wanted them to do. So some advantages of the Jupyter Notebook are you can execute the code not line by line, but paragraph by paragraph. You can use a library called pandas to create data frames in Python. There's a wide range of graph plotting libraries available, so if you can dream it, you can probably make it. And I just finally said that IPython is the name that it used to be known by. So the disadvantages, I thought, was very limited support for animated and interactive graphs. You can see here, they're making some. If you go to the Jupyter website, you'll see that they've got widgets, but there's very limited amount of graphs that they've got. So back in April, I was at the DataWorks conference, or DataWorks Summit, by Hortonworks, and one of the evening talks was by this guy called Bernard Walter, and what he showed was an alternative to using the Jupyter Notebooks called Zeppelin. And if you're in the Hadoop world, you may well have come across Zeppelin, but you can still do this with just ordinary Python. You don't have to use Hadoop for it. So what I'm going to do is I'm going to jump into a demo at this point. So I've got setup instructions in code. Now I haven't updated the link because I want to double check that everything's right first, but if you make a note of the link, then I will put instructions for you to be able to do this yourselves, if you want to, okay? So let's jump into the demo. So this is Zeppelin notebook. It's very similar to a Python notebook. A Jupyter notebook. The big difference, it comes out of the Apache, so it's an Apache project, and more commonly you'll find that it's used with people using Spark and Hadoop. And what I've done is I've set this up in a way that it's really easy. So Zeppelin doesn't run on Windows, but what I will provide is about 3 lines of code for you to download a Docker image, Docker container, and then you'll have some setup scripts, which is again 4 or 5 lines of code that you'll run, and you'll have this. So you'll be exactly where I am. So you're talking about 3 lines of code to download a Docker container and another 4 or 5 lines of code for a startup script, and that's it. Okay, so quick intro to Zeppelin. Zeppelin is very similar to Jupyter Notebooks, but with one example, or one big exception, and that is that you don't have to choose the language. You can actually have every paragraph having a different language if you want. So I'm going to jump into my second note. My second note is how to install the Python libraries. So the way I've got this set up is actually the container allows you root access to the underlying, so it's a Docker container with a Debian image, and in that Debian image is Hadoop and Spark and Python. So it's all ready to go. These libraries here really are, so if you do a %sh, you're running a shell command in the container. So these are installing various different Python libraries. So pip is a package manager for Python, and it's installing various different libraries. We're even doing an apt-get, although the only apt-get I'm doing is for Git. So installing Git, and then we're cloning a few of Bernard Walter's libraries that we're going to be using later. So all you've got to do is run those scripts, and then let's do some data analysis. Right, so the first one I would like to look at is we've got Titanic data set. I think this is an easy one for people to understand. So at this point, I'm going to try and explain to you why I like Zeppelin better than I like Jupyter Notebooks. Zeppelin notebooks are based upon Angular and Bootstrap, whereas Jupyter Notebooks have been around a little bit longer and they're based on jQuery and less. And that means that it's a little bit more adaptable. You can inject Angular code into the notebooks. So we'll try running a few of these. So the first one here is I'm simply reading some CSV file, and I'm reading into a Titanic data frame and printing out. This is all the data from that CSV file. So we go on down to the next section. Here I'm creating from that a Spark data frame. So the first data frame is a Pandas data frame, and the second one is a Spark data frame. Now you don't have to do this in order to get the demo working with the data coming in, the IoT data, but the nice thing about if you do create a Spark data frame, you can then do SQL on it. And if you do SQL on it, built into the Zeppelin notebook, there is, it's called Helium. It's a little tool that gives you table view, and here we've actually got some data that I can, so you can drag and drop the columns that you want, and it creates the graphs. So if I start again from scratch, you could potentially drag in passenger class. We could look at the sum of the people that survived in each passenger class 1, 2, and 3 on the Titanic. You can further break that down by 6 if you want. Oh, I've done this the wrong way around. I think it works better if I do 6 here and passenger class here. There we go. Okay, so very quickly you're able to get a feel for the data. Like I say, you can't see trends from tables of data. So that's a step along the way, at least. The other nice thing about Zeppelin notebooks is what I can do is I can put in a little bit of code like this into my SQL, and now I've got a box that I can that I can change. So you can see there's 3 stops where people go on to the Titanic. There's Queenstown, Southampton, so let's do Southampton, and you can see the number of people that got on in Southampton. Okay, and then you can graph that as well. So that's a little bit of Angular going into the page that allows you to adapt your graph. So that's a kind of a nice trick as well. So I'm quickly going to show you some stuff from Bernard. We'll maybe go to the second one. We'll start with the first one. So this is his information is beautiful presentation that he gave, which seemed great, but actually it took me quite a while to figure out how his computer was set up to get this to work. But he quickly ran through this and I thought this is fantastic, but when I actually tried to do it myself, it was a little bit more tricky. So what you can do is you can check versions, you inject some Angular, and no, I'm going to jump to the second one, just given the time. So what he's actually done, how many minutes have I got left? 5? 5, right, so we're going to go to my one. We're going to go straight to the sensor tag example. So what he did was he created some libraries that allow you to store data in the session object for Zeppelin. So first of all, you run that, you start the session, you get the working directory that we're currently in, which is user/Zeppelin. You can load in some data from sensortag.txt. So obviously, because I'm in the conference, I wasn't going to trust conference Wi-Fi. So I saved the data from the sensor tag that I gathered into a text file. So what we've got here is just taking that data and spitting it out. So it's all been read into one big list of data. So I'm just showing you here that if I take the first 8 items, because there's 8 sensors on the sensor tag, that's a sample of the temperature. You've got infrared and ambient, you've got the humidity, you've got barometer, you've got accelerometer, and so on. In the next section, I'm just creating some functions to make it easy to extract that data. Just printing it out, that's the data frame, printing it out. Here, what I'm going to do is take the data and read it into a Spark data frame, so I can do some SQL on it. It's pretty good. Right, now into the stuff that Bernard gave. There's 2 libraries that you can use to create the visualizations. One of them is based on D3.js. I don't know if you've come across that or not, but most graphs on the web are done with D3.js. It's very versatile. There's another project called NVD3, which makes the graphs a little bit more reusable. So the sort of thing that we're trying to do here, to take graph data and quickly manipulate it and reuse it. The NVD3 framework works pretty well. And Bernard has made a wrapper for that for integrating with Zeppelin. So what this bit of code is doing is loading in his library that gives you the D3.js functionality. And at this point, it's really, really easy to create line chart data, or various different charts actually. And the reason it's so easy is because you just get a little bit of, it just looks like a little bit of JSON here, but you can see you just set the y-axis, the x-axis, the height, the range on the y-axis, and there you've got your graph, and it's actually interactive. So that's what we're aiming to do. Now, that's kind of good, but that's me taking all of the data in. The next thing that I thought I would do was, what if I just take, say, 60 seconds of data, and then what we can do is, with this little loop, so you basically just have your data frame and you start appending to your data frame. And if you do that, what happens is the graph automatically updates. And that was what we were aiming to get to. So it's a nice, really simple, really easy way to do it. The NVD3 framework is pretty good. It gives you lots of graphs, but there is a limitation to it. You know, you can't just do anything you can dream of. There's another framework called Bokeh, which again, I will package up with this. But if you look at Information is Beautiful version 3, that is an integration with Bokeh graphs, and you can pretty much, if you can dream it, you can probably make it in Bokeh. And again, you can have interactive graphs, and you can also have them that the data gets imported in live in real time. So that brings me to the end of my presentation. Hopefully you were able to keep up. There was quite a lot in there. Have we got time for any questions?
We do indeed, yeah.
Okay. Yeah, sure.
Where did you come to your conclusion that you can't derive any analysis from data?
It's not easy to see trends from tables of data. Like most people can't. One of the rules I live by is that you shouldn't make the end user do the processing. So you want to hand the data, certainly was my experience in the hospitals, where you want to hand the data to people so that they look and they go, yeah, I get it. But it's very hard to see from a table what the trends are, unless you can hold them all the rows in your head.
So you're talking about a physical table?
I'm talking about a table of data. If you read it, people cannot look at that and just go, oh yeah, I see what the trend is.
Right.
More times than not.
It was just a very vague statement.
Yeah. Sorry.
That's
I hope I've clarified.
I wanted to get to the understanding of it instead of give you a really hard time about it.
Okay.
Your little sort of toddler sensors.
Yes.
Were they Wi-Fi enabled or Bluetooth? And if they were Bluetooth, what were you using as a based?
Raspberry Pi. So the boys had to be in the same room. So I mean, it was a bit of fun. Yeah, they were. It was just a way of generating some random data, and I tumbled them around a bit, and they loved that. So. And a big bit of double-sided sticky tape.
What was your conclusion from the data from the kids?
Well, you can see here that it truly is random data. I don't think you could have got a random algorithm to just generate just as random as that, I don't think. Yes?
Have you looked at our training programs that we've got out?
Yeah, I have a little bit, but I'm not aware of being able to take a real-time feed in. Can you now do that?
Means and ways.
There is.
There is, yeah, but you have to keep reapplying the art code over and over, and it can get intensive. And then obviously art doesn't scale well.
But that's one of the issues, and one of the reasons why I was keen to go from R to Python was just the versatility of Python. You know, so I'm leaning a little bit more that way, just because there's more stuff you can do with Python.
How can you share this visualization?
It's not really designed for sharing the way this is being done. This is more for, like I said, the problem that I was trying to solve was I'm building something and I want to analyze the data, and then at some point in the future we're going to build something for production. But this was just a quick way to visualize the data. This framework, the NV3 D3 framework, is super easy. It's really quick to throw up a visualization, see what's happening. Sorry?
What was the other framework?
Bokeh, B-O-K-E-H, which again, it's a little bit more difficult to produce the graphs in. So if it had another R, we could have maybe tackled that.
Sorry.
Time's up.
That's it.
Thank you very much.